in this video we are going to talk about the average velocity in one dimension. It means that the object is moving in a line in one dimension, in a line. So first of all, we are going to introduce the concept of interval of time. The concept of interval of time is defined here as delta t. It's the time elapsed between one situation at time t1 and one situation at time t2. For example, suppose that the object is here at time t1 and now appear at time t2, it appear in another position. So this will be r1, this will be r2. There is a time elapse between this position and this position, and the time elapse delta t, also delta, means the change in time. The change in time is maybe from t1, that is 12 o'clock, to t2, that is maybe 12 o'clock and 1 second. So in this case, delta t will be 1. If the change of time, for example, at t1 is 12 hours and 2 seconds, 12 hours and 2 seconds, and at t2 is 12 hours and 5 seconds, the change in time will be 5 minus 2 will be 3 seconds in this case. So the change in time is just t2 minus t1. This is the change of time. And it's an scalar, But take care, delta t is always positive. You cannot go in a problem back in time. You go always forward in time. So delta t is positive, meaning that t2 is bigger than t1 always. So let me put it here. Okay, t2 is bigger than t1. So what does it mean, time in this problem? Time is like a recipe. It's like when you make a cake, you need flour, and you need eggs, maybe, and milk, maybe, to make a cake. Well, to make a change in position, you need time. If you don't have time, interval of time, you need delta t to make the change. You need change in time, the change in time. So if you don't have change in time, you cannot make a change in position. So delta t is the change in time and is related with the change in position, and we'll see in what way. We'll see it in very easy example. Suppose the position of the particle that is that x1 equal 1 meter at the time t1 equal 2 seconds, and x2 equal 5 meter at the time t2 8 seconds. I want you to figure out how you will do this. Find delta x. Oh, very easy, we have done before. Find delta t. Delta t is the change in time. The change in time is from 2 seconds to 5 seconds. How much it will be the change in time? Well, it's here, t2 minus t1. And find the vector displacement. Let's go to do this problem, and we'll solve it, and we go forward. 2, yes, is x2 equal 5 meters. So this is our problem. The t1 is 2 seconds, and it's at the position x1 equal 1, and at time t2 is 8 seconds, and it's at the position x2, I suppose x2 equal 5 meters, I think is correct. So what we have to do is to calculate what the problem asking. The problem asking, what is delta x? Well, delta x is from 1 to 5. From 1 to 5 there are 4 meters, so delta x is 4. So it's x2 minus x1. 5 minus 1 is 4. Easy or difficult? Easy, of course, that is easy. What is the vector delta r? As I told you in the previous video, not the previous to the previous video, delta r is delta x by y. How much is delta x? 4. 4i is the displacement. So the displacement is just this vector. This vector is the displacement vector. This vector is 4i. So very easy. And what is the chain of time? The chain of time is also very easy. It's delta t is t2 minus t1. t2, 8 minus t1, 2 is 6 seconds. The interval of time elapsed from position x1 to position x2 is delta t equals 6 seconds. If this is clear for you, you can continue. If it's not clear, go back, please go back. So we define now the vector average in one dimension, the average vector velocity, like the average vector velocity in one dimension, like the chain in space divided by the chain of time. So the displacement x2 minus x1 divided by the chain of time. So we write this in vector form. So what we are doing exactly is like this. Let me explain you what we are doing. What we are doing exactly is like this. You see R1 on this picture? Yes. You see R2 in this picture? Yes. So the object was here and now was here. There is a chain in position? Yes. What is the displacement vector? The vector that says what is the chain in position? This vector, delta r. Delta r is this vector. But the problem is like this. Suppose that at time t1 the object was on this position R1, and at time t2 was in this position t2. It's possible to cover delta r with another vector v that we call v in a way that if we multiply v times delta t, we'll get delta r. Of course, we get a small v here. We multiply whatever it says delta t between this, and this vector v is the vector that delta t times v is converted in delta r. So it's like a machine. V is like a machine. You multiply v by delta t and you get the displacement vector. And this is the equation. So that's why we define v as delta r divided by delta t. So v is the vector that if you multiply by the elapsed time, by the interval of time between two positions, you multiply v by this elapsed time and you get the space, the displacement vector between these two positions. So in this way, we define v like delta x divided by delta t, the displacement in x divided by displacement in time. And the vector v in one dimension is this quantity that could be positive or negative in the I direction. When it's positive, not when delta t is negative, because delta t is never negative. This quantity is positive if delta x is positive. When delta x is positive, when x2 minus x1 is positive, delta x positive means that x2 minus x1 is positive, means that x2 is bigger than x1, means that the object is moving to the right. To the right, correct. And when the vector v is negative, the vector v is negative not when I is negative. No. The conversion to minus I is here in this way. If delta x, if this delta x is negative, so this will be negative divided by something that is positive. Everything will be negative, and v will be minus I, minus 3i. So if we write down here, if delta x is negative, means that x2 minus x1 is negative, means that x2, the final position, is smaller than the initial position, means that the object is moving to the left. Correct. We'll do some problems to practice. So let's go to the next page to practice the problem. So let me see what else I have wrote here. Let me see, please, let me see just a moment. I have wrote that Bx, the component x of the vector, is this thing. This thing. So the V is Vx by I. And the component is delta x by delta t. This is the component Vx, delta x by d. And what is delta x? Is x2 minus x1, x final minus x initial, divided by t2 minus t1, t final minus t initial. Or what is the same? Delta x divided by delta t. Let's go to see what I did here, and here what I did is a simple example to show you how to use this equation. In the first equation, the example is like this. You have an object. The object is an x equal 1 meter. And it ended in x equal 5 meters. The object is in x equal 1 when t1 is 2 seconds, and x equal 5 when the final times here is writing, when the final time is 8 seconds. So it's clear that delta x is this vector, delta x, and the vector delta x, the vector delta r is 4 times I. It's very clear for this. So I ask, what is Vx and what is the vector velocity? So very easy to find with what I said. So let's go to do it. So delta x, let me put my symbol. So delta x, the quantity is positive 4. So going to the right. 4 unit point to the right. And the vector delta r is 4I. And the magnitude of the vector that we call Vx, and we call Vx because the velocity is on the x direction. It's one-dimensional problem, but it's on the x direction. The velocity Vx is the change in position divided by the change of time. What we are saying that these 4 meters can be covered with a vector velocity that have the magnitude 4, 6, 2/3 meters. 2/3 meters, 2/3. So it will be like this. This is the vector velocity here. If you multiply this vector v by how much? How much is the time elapsed? The time elapsed is from 8 seconds from 2 seconds to 8 seconds. It will be 6 seconds. If you multiply v by delta t, you will obtain delta x. So v is 2/3 because it's delta x by delta t. So if we multiply by delta t, delta t will be 6 seconds. 6 seconds. 6 will be 4 meters. So, and 4 meters is delta x. Okay, check it. So you have to visualize that the vector, the average vector Vx, is in the direction of the vector displacement. In this case, you will see more clear in 2 or 3 dimensions when we go zoom to 2 or 3 dimensions. So what is the vector V? So we found delta x, we found delta r, and what is the vector V? The vector V is the vector that has this magnitude, 4, 6, and is in the I direction. So the vector V is always, V is Vx I. This is the vector V in 1 dimension. Let's go another problem. Conclusions. The vector delta r, the displacement vector, is a vector that... So the 2 conclusions that you have to keep in mind is the 2 following conclusions. The vector delta r, the displacement vector, is the vector that when you add delta r to r1, the initial position, plus the change in position, you will obtain r2. r1 plus the change is r2. And the vector velocity is the vector that alpha times b, you will get delta r. And what is alpha? Alpha times b is the vector delta r when alpha is delta t. So if delta t is 3, 3 times b will cover delta r. 3 times b will cover delta r. So this is the equation that you have to take care. For example, if delta t is 2 seconds, so v is this vector because 2 times b is delta r. 2 times b is delta r. Delta t2 by b equal delta r. So 2 times b equal delta r. If delta t is equal 3 and this is delta r, you divide delta r in 3 parts and 3 times b will cover delta r. So this is the idea that is behind of a vector velocity. And the next page is just a page, a very easy example to practice all these concepts in a very easy way. So in this case, I will give you only delta r. Delta r is 10i, the vector 10i. I don't have to tell you what is x1 and what is x2. Delta r is the vector that if you apply to x1i, you will obtain x2i. So delta r, it can be 10i, but what I mean is that if this is 3, this is 13. But if this is 13, this is 23 in the x direction, okay? So I'll give you only the vector delta r like 10i. I ask you to find the vector velocity in the following case. Suppose that the delta t, t1 here in x1 and t2 is here at x2. So there is a function x of t, x of t1, and there is x, the position x at t1 is what we call x1, and x of t2 is what we call x2. So the problem here try to make you to figure out how the vector velocity works. And the vector velocity works in a way that if you multiply v by delta t, you will obtain delta r. So delta r is known, is 10i. So the problem here, the example, try to exploit this idea. If delta r is 10i and delta t is 10 seconds, which one is v? Very easy. V will be the vector that will cover in 10 seconds the distance delta r. And which vector is this one? The vector v is the vector delta x divided by delta t in the I direction vector v, x. So in this case will be delta x. How much is delta x? Is 10 divide 10 delta x divided by delta t, 10, so is 1i. The vector 1i is the vector velocity because 10 times 1i will be 10i. Well, make it like this. If you make it like this, it will be the same thing. But this is not an example. It's not your homework. Sorry. This is an example. So what will be Vx in this case? Well, Vx will be delta x divided by delta t. So Vx will be the vector that covers the complete distance in the time elapsed. The time elapsed is 2 seconds, and delta x is 10, so this is 5. So the vector velocity is a vector that has the magnitude 5 and goes in the I direction. Vxi. This is the vector v. Okay, what happens if delta x is negative? If delta x is negative, it's because delta r is minus 10i. So means that the vector is not this vector, is this vector going to the left. In this case, all the signs are negative because delta x is negative. Okay? Okay, so here we solve the problem completely. This is the delta r, this is the delta r, 10i. So I draw 1, 2, 3, 4, 5, 6, 7, 8, and 10i. An I vector, the I vector maybe is on the x direction, and maybe it's this vector I, and this is the same line, okay? And this is delta r, but I don't have to tell you where is x1 and x2. This is delta r, the chain position. This is the vector that takes any point in x1 and convert it in x2 through the relation x2i equal x1i plus this delta r. This is, I don't have to tell you what is x1 and x2. This is the chain in position. So if delta t is 10 seconds, what is the vector that will cover in the time elapse of 10 seconds in this interval of time that will cover the 10i? Well, the vector 1i. Why? Because, of course, because the vector, the chain in displacement, delta xi, is the vector v by delta t. So if v is 1 by 10 is 10i, and will cover completely, will cover the 10i, because v by delta t, 1i by t by 10 will be 10i. It will cover. What happened now in the second case that delta t is 5 seconds? In the second case, the displacement vector is still the same, it's 10i, but this displacement vector have occurred in half of the time, in 5 seconds, not in 10 seconds, in 5 seconds. So now the vector velocity is delta x divided by delta t is 2i. What does it mean 2i? It means that if you multiply the 2i 5 times, 2i will cover the completely 10i, because by 5 by 2, delta t by v will be delta r. So the vector velocity that will cover in the time delta t the whole displacement will be the vector velocity that will cover in the time delta t of 5 seconds the whole displacement will be the vector 2i, because the vector 2i by 5 will be the complete displacement. What will be the vector when delta t is 2 seconds? It will be again the vector 5i. And what will be the vector delta t if delta t is 1 second and you make this chain in position in 1 second? The vector will be 10i. As you see, the vector starts to be 1i, grow up to 2i, double, 2i, and now on the third case, C is 5i, or I cannot draw 5i, but 5i, let's say 5i, and finally it's 10i. It takes 1 second to cover the whole displacement, 10i. So this is the vector velocity, and this is the displacement. The displacement, because delta r is v by delta t. Correct. So on the next homework, no, to see what is the problem that I proposed you to make. 2.1, 2.2, 2.3, I think you can make it. I think that you can make it. Go ahead and good luck.